So I want to welcome all of the various cohorts of graduate students to Psych 520, which is basically a research methods class, but mainly focused on statistical techniques and statistical tools that we can use as science practitioners. And again, though all three of the actual graduate programs are focused on primarily creating practitioners, people that are going to apply psychology to real world problems, we all are built around the science model that we want to also make sure that you fully kind of have a strong basis and understanding of how to do research, how to do academic research, how to do applied research, and how to read and understand research. And honestly, one of the best ways to really get a good feel for what a research study is doing is to actually know how to have done it yourself, to understand the methodology and to understand the statistical techniques that were used to provide the information. So even if you never plan to do research beyond your master's degree here, it is still a good idea to have a good solid understanding of these concepts. Also, having a strong statistical skill set does make you more marketable over people that do not. So a lot of graduate programs, honestly, in the field of master's degrees in psychology, often will only have a single statistics class, and honestly, it's not very rigorous. We're going to get into some pretty major statistics in the next year, both in Psych 520 and 521, and my main goal is to focus on not two things really. So I have two main goals. The first one is truly understanding how these techniques are used, being a better consumer, but also how do you actually use them? How do you have enough skill to where if someone asks you to do a logistic regression, you may not be able to know immediately how to do it, but you've done it, you understand it, and coming back to the textbook and the notes, you'll be able to do it. So of course, a part of any process is, as far as a new class, is getting to learn each other. If you're watching these lectures before we actually have our Zoom meeting on Thursday, that's mainly what we're going to be doing. However, I kind of just put together, like I do for all my classes, just kind of a collage of pictures taken from social media to give you an idea of things that are in my life, things that I enjoy, things that I do. I'm generally a fairly direct person. It's very rare that someone asks me a question that I'm not willing to answer. So if you have any questions about me, either professionally, about this class, or just to learn a little bit more about me, I strongly encourage you to go ahead and ask. I'm probably very willing to answer. So we're going to go over kind of the basics of where we're moving forward and some of the basic kind of key concepts that are going to be throughout this class a major part of your understanding. So again, this is Psych 520, Research Design and Inference is one. This class has never been offered in an online format before. Different times require different methodologies, but I do want to make sure that you understand that I want you to feel as connected as possible to your cohort, to your fellow students, to the teaching assistant, and to me. So though most of this course is going to be asynchronous because I think that works better for everyone's lifestyles and for their work schedules, I definitely want you to feel that you can ask questions at any point. For every lecture that I post, there will be a discussion board for questions, and I strongly encourage you to use that if you have any questions about the lecture. That way, not only do the other students get to see your question, because they may have had it too, they just weren't willing to ask it, they'll also be able to see my response. If you need to meet with me privately via Skype or Zoom, in person or via email, I am very available. I also want to make it clear that this class is being co-taught with a second-year graduate student who is primarily in charge of running the labs, and the labs are focused on the application of what we're learning. So I mainly focus on the theory, the why, the understanding, what's going on, while at the same time during the labs you're going to be doing homeworks and assignments where you practically do the techniques we're talking about so that you understand what happens when you put this data into a data software program. Specifically, we'll be using SPSS. So I want you to really understand that it is co-taught. I do not think of the TA as a lesser person than myself. We are two instructors. I'm focused on theory and she's focused on the practice. So I also encourage you in every possible way to also reach out and make sure you stay in contact with the TA, especially when it regards the homeworks and the lab assignments. Broadly speaking, the points in this class, There are 8 homework assignments. Each one is worth 25 points for a total of 200 points. And there'll be 3 fairly exhaustive open book exams, each one worth 100 points, where you apply the various theory that you're learning in these lectures and application, doing the actual statistical analysis and interpreting the outputs in a test format. So let's talk a little bit more about me. My name is Joel T. Nadler. I have a degree in IO psychology. Technically, I have a degree in what's called applied psychology with a focus on advanced quantitative methods and psychometrics and industrial organizational psychology. I am a graduate faculty in the industrial organizational psychology program. And just for something a little bit different, because this class is mainly focused on statistics, and I'm also a bit of a fan of history, we're going to talk about degrees of separation. So there's a common game, and I'll get to that in a minute, that uses the degrees of separation, but this actually comes from a psychological study done by Stanley Milgram. So Stanley Milgram is the same guy that did the obedience studies, where people thought they were shocking people. He did a degrees of separation study where he sent out randomly envelopes to people that then also asked them to get that letter to some other person randomly. So he would grab a random person from the United States and then another random person from the United States. So let's say he grabbed me. I would get a letter and it would say, get this letter to Jane Smith in Los Angeles. And if I didn't know Jane Smith, my only goal was to send that letter on to whoever I thought would have a better chance of knowing Jane Smith in Los Angeles. And when you got this letter, it included instructions, and it included all self-addressed stamped envelopes, so it didn't cost you anything to do this. And a lot of people did it. And if you were the one that was supposed to get the letter, if it actually got to Jane Smith, the final envelope was to send back the information of how it got to you. And what Milgram found was that the average degrees of separation of any 2 random people in the United States was less than 6 steps. That most people, so again, if I was trying to get it to Jane Smith in Los Angeles, I actually know a person right now that lives in Los Angeles. I would mail it to them. And they probably wouldn't know Jane Smith, but they'd look at the address and go, they live on the east side of Los Angeles. I know someone lives there. I'll send it to them. And then that person would go, well, they don't live in my neighborhood, but I know someone that lives in that neighborhood. I'd send it to them. That person would go, well, I don't know that person, but I bet they work here, and it got to them. So the idea of degrees of separation as a fun party game actually started as a psychological study. So just a little bit of my background as far as a statistician and someone teaching stats classes. I've actually taught graduate stats classes at multiple universities. And I have 2 degrees of separation from statistical greatness. So my 2 mentors when I was in graduate school, who I learned stats from, was Josephine Korchmaros, and she got her degree from David Kinney. We're actually going to be reading one of David Kinney's papers, and he pretty much created the most common technique we use when investigating moderation and mediation. I also learned statistics from Dr. M.H. Clark, and she actually got her degree from William Shadish. And William Shadish is probably one of the biggest names in applied statistics. So he is a program evaluator that has worked very closely with multiple people in the United States government to do program evaluations of federally funded nationwide programs. Now, you might be more familiar with the degrees of separation in the game Degrees of Separation from Kevin Bacon. So I did that as well. So I have 4 degrees of separation from Kevin Bacon. I have a close friend in Los Angeles that actually is in the film industry. He's not been in anything where you'd recognize him immediately, but he's been in a bunch of movies, basically as bit characters, side characters. He does a lot of stunt work as well. His name's Brent Lappin, and he was in Army of Darkness with Bruce Campbell. And Bruce Campbell was in the Hudsucker Proxy with Sizemore. And Sizemore, of course, was in Crazy Stupid Love with Kevin Bacon. So I have 4 degrees of separation from Kevin Bacon. Also, through my relationship with Dr. M.H. Clark and her relationship with William Shadish, I have 2 degrees of separation from Governor Arnold Schwarzenegger because he also is close friends with William Shadish. So anyway, just a little bit of kind of how the history of psychology sometimes is hidden behind things that we take for granted, and just a little bit more about me. So obviously, if you have questions, you can use the discussion board. So let's talk about statistics. So this is going to be our introduction to advanced statistics, and for the first 2 or 3 weeks, we're mainly going to make sure that everyone has a really good understanding of what I would consider to be primarily undergraduate statistics: correlation, regression, t-tests, and ANOVA. And in fact, a fair amount of this semester is going to be a deeper dive on those techniques. So we're going to be talking about the types of quantitative analysis, and quantitative analysis basically means that our outcome is numerical. So that's the first thing, is that we can broadly define research into qualitative. Our outcome is not numerical. It is actually rich data, it is verbal data, it is observational data, versus quantitative, where we have basically assigned numbers to units. Now, a lot of times we start with qualitative data. We have observations, but then we quantify it. So if you're a professional judge watching a boxing match, you're watching qualitative data. You're watching performance and dodging and punching and different types of punching. But at the end of each match, you score it on a 1 to 10 scale. That's putting it to a numerical quantitative level. We're going to talk about making causal inferences. So a causal inference is when we look at statistics, and then because of the methodology or how we conducted the study, we can actually infer from that study a causal relationship between what we examined. And we'll talk about what you need to have a causal inference and when you can't make a causal inference. And this is probably one of the biggest mistakes that we see in statistics across all mediums of discussion. So people making causal inferences when they don't actually have the requirements to make such an inference. We'll talk about the language of hypothesis testing. We'll talk about how power affects the significance of our findings and what significance is. We'll talk a little bit about the various types of data, and we'll talk about some of the antiquated terminology that we'll sometimes use when we use descriptive statistics. In other words, we'll talk about distribution moments, which is kind of an odd term, but moments basically means ways to describe a distribution, descriptive information. And finally, we'll kind of define what is parametric statistics, because that's what we're mainly focusing on. And parametric statistics, again, is another way to say it's a quantitative study, that our outcome is actually numerical. So let's talk about the type of quantitative studies. So we can have descriptive versus inferral. So descriptive is, again, anytime we've assigned numbers to human behavior or outcomes, we can then start doing descriptive data. We can look at the mean, if we can get an actual mathematical mean. We can get the median, we can get the mode, we can get the standard deviation, we can get range. And again, what techniques we use depends on specifically what type of quantitative data we have. And we'll talk about that a little bit as well. But just recognize that there is no problem with having a descriptive study. But all a descriptive study is it describes behavior. It describes how often are people getting A's, B's, or C's. That doesn't give us any information about actually inferring what causes someone to get an A, B, or C. It simply defines it. Inferential statistics is looking for patterns and whether a pattern that you find in your data can infer to other groups of data. If you find that a particular variable predicts performance in a class, could you infer that that same behavior would predict performance in other classes? If you find that adding a study guide to a class results in a 10-point increase in performance on tests, would that same study guide work in other classes and other fields? So inferential statistics are looking for patterns generally between multiple variables, both independent variables and dependent variables. Another way to think of independent variables and dependent variables are our predictors. They're the things that we think are going to impact or change an outcome variable. So the dependent variable is the outcome we're trying to predict or the outcome we're trying to affect. So from an applied viewpoint, almost always when we're doing statistics, we're looking at predictors on some desirable behavior. What can we change in an environment to cause an improvement in an outcome? And inferential statistics, and again, these are all parametric statistics, at least the top, t-tests, ANOVAs, Pearson correlations, and regressions. But we also have some non-parametric, which means, again, the type of numerical data that we're getting is not continuous. So parametric statistics are quantitative studies in which the outcome variable is also continuous. The numbers have meaning. Less of it means less of something, more of it means more of something. Non-parametric statistics include chi-square, Spearman correlation, and those are when we have categorical data. In other words, we assign numbers, but the numbers really don't mean anything. 2 is not better than 1, 3 is not better than 2. That would be a non-parametric statistical test, but we can still test for patterns, inferential data. And again, there's two things we can do with inferential data. We can simply look for patterns and relationships, identify them and describe them, or if our methodology is correct, we can talk about causation. In other words, the IV caused the change in the DV. They're not just related, there's a causal chain. So the research project process in general goes from a conceptual to an observable range. So basically, we have initial observations. Initial observations are collecting data, but they're really more about just learning about the environment. They might be literature reviews, they might be observing behavior in the wild, in the natural. And from that data, from that research, you start to create research questions. You start to ask, I wonder what predicts whether someone does well in a class. What particular variables that predict whether you do well in a class are something that I might be able to intervene on? Because again, at all times, we're wanting to think about how do we apply this process to make the world a better place. Once we have those initial observations, we have some research questions, we're going to go back into the literature at that point, looking for people that have researched this before, what theories of human behavior are there, and from those theories, we're now going to take those research questions into testable hypotheses. And hypotheses are the process of moving towards actually creating a study. The hypotheses should still be in the level of constructs. They should be in the level of theory, but they start to identify variables. For example, the more you study, the better you'll do on a test. Well, we're not specifically deciding what test, we're not saying what type of study, but we are starting to define that studying has a causal relationship on performance. Once we have our hypotheses, we then generate predictors. We actually operationalize the study. What type of study guides are we going to use? What type of studying? How are we going to enforce it? How are we going to motivate it? And what kind of test performance? How are we going to measure it? And how are we going to look for that relationship? Once we've generated our predictions and once we've operationalized our study, we now know how we're identifying studying, how we're measuring studying, how we're bringing study into the study, and how we're going to measure test performance. We now do our study. We collect the data. We actually, for example, randomly select half of the people to get a study guide or a series of study aids. The other half of the students randomly do not get that study guide. And then on the next test, a test of knowledge of 100 items, we look to see if there is a reliable difference between the group that had study guides and the group that didn't. We measure the variables. We then analyze the data. We graph it and see, does it support our hypothesis or does it reject our hypothesis? And at that point, if it supports our hypothesis, we want to get that information out there to add to the literature review of theory. If it doesn't support our hypothesis, we probably want to go back to the drawing board and try to do the study again or try to look at another predictor in the theory that might actually get the result that we want. In this case, increase in performance in tests. So the final component of that is making causal inferences. So statistics does not allow causation. No statistic gives you causation. Statistics tell you how likely a pattern is to occur due to chance versus a meaningful relationship. So determining causal inference is a methodological issue. And Mill's canons, so John Mill created the logic of causal inference in a paper quite a while ago. And basically what he said is that his canons are you need 3 things before you can claim causation. The first is where stats live. You do need to show there's a relationship. So if there is no reliable pattern, or if the pattern you find could very likely be due to chance, you can't talk about cause. But if you have a pattern and that pattern is reliable, it's trustable, you have enough data and the pattern is clear enough that it is unlikely to have occurred due to chance, that lets you move on to the second canon. The cause has to precede the effect. Now that's a pretty simple sentence, but it's a pretty meaningful one methodologically. Any study that exists that studies pre-existing variables, if you're looking at gender, male or female, if you're looking at social economic status, whether you grew up in a well-to-do house or a not well-to-do house, if you're looking at the difference at people that live in Alabama versus the people who live in California, none of those are causes that you can show methodologically precede the effect. So you can't show that gender happened first to an outcome. So in order for you to be able to prove methodologically that your cause preceded the effect, you have to be able to assign and control the cause. And this does limit what we can do as far as truly causal inferential studies. A lot of times the only way to truly get at cause are in very tightly controlled lab setting studies. Now, if you have a pattern, if you've made sure that the cause precedes the effect because you introduced the cause, and you know it preceded the effect because it happened first in your study, then the final factor is you have to rule out any alternate explanation. So anything else that might have varied in your study could be what we call as a confound. It could be another explanation for what happened. And you have to rule those out. And that again tends to force us into a highly controlled lab setting. So for example, if I was interested in looking at the differences between study guides and not study guides, so that's something I can control. I can assign whether or not you get a study guide. So I can make sure the cause precedes the effect. I assign or I don't assign a study guide prior to you taking a test. I then give those study guides, but the way I do it is I try to use random assignment. I find out my organization won't let me do it, and they basically say, I'll tell you what, you can use study guides in the class that you teach in the morning, and then just don't use study guides in the class that you teach at night. So I do the study, and I find indeed that those that had the study guide scored higher. So the morning class that got the study guides did better on the test. The variables co-vary. In other words, those that got the study guide did better. Those in the evening that did not get the study guide did worse on the test. And the differences in their performance are very unlikely to chance. That's what our statistics tell us. I haven't ruled out alternate explanations though. It could be morning students are more motivated. It could be that in the morning they were a little more awake and that my evening students were a little more sleepy. So it might have had nothing to do with study guides. I didn't rule out an alternate explanation. So really the only way with that particularly simple study that I could truly get all of Mills' canons is everyone would have to have an equal chance of getting the study guide or not randomly in the same class at the same time. I would need to also make sure that those that got the study guide did not share the study guide with those that didn't get the study guide. I would then need to give them the test, and then I'd need to find the pattern. I would then have the ability to make a causal inference. Just recognize that to make a causal inference, we often have to set up a kind of unnatural, very controlled situation to get there. So a lot of times we want to ask the questions, can we get closer to causal inference as we design a study? But also recognize it comes at a cost. To truly get to causal inference, to truly answer all of Mills' canons, we usually have a fairly unnatural lab setting feeling study where people know they're in a research study. So broadly speaking, Mills' canons break down today as 3 terms. You have to find a statistical relationship. You have to establish temporal precedence. Your IV came before your DV. And you have to rule out any other potential logical confounds.